Okay, so let's do some more PSKoans. It was fun the last time. I've been playing a bit with XSplit and setup, so I've added some music and some chat and even a splash screen, as someone may have noticed. So let's see how this goes. Please put in a chat or something if the sound is too high, or the music is too high. I can't really tell, unfortunately. So let's continue with some PSKoans. The last time we ended on about order of operations. So let's see what's next. So measure karma. We should be getting some. There's an update, by the way. I'll update the module first. Let's see if we can get some. Great, thanks. Oh, this is nice. Waiting for stuff. So the next thing is supposed to be arrays. So we need to go to AboutArrays. So let's start from the top while the module is updating. Arrays and iterable collections. Like many programming languages, PowerShell often uses arrays to keep collections of objects together. Arrays tie in closely with PowerShell's pipeline, which is one way to iterate over a collection with a good deal of efficiency. There are a few array-like collection types available in PowerShell, all of which are rooted in .NET classes and data types and behave much the same as they do in C# and VB.NET. Okay, I think the mic is actually. Is there a gain button on this? Let's try. No, it's on max there as well. Maybe I need to pull it closer. See if we can get it closer without it entering the video. Okay. Well, it's closer now at least. So, we're done with the update. There are a few array-like collection types available in PowerShell, all of which are rooted in .NET classes and data types and behave much the same as they do in C# and VB.NET. Arrays in particular have a close relationship with the PowerShell pipeline, which will be covered shortly. It will probably be covered shortly. I'll make a note and create a pull request for some grammar updates. So, describe arrays. It is useful for grouping related objects and values. The comma operator is used to create an array. Spaces are typically ignored. Individual elements of an array can be accessed with a square bracket index syntax. Arrays are zero indexed. The first element is at index 0, the second at 1, etc. So ages 0. In this case, we have a variable or an array called ages, which contains 12, 25, 18, and 64 in that order. So ages 0 should be 12. And ages 3 should be 0, 1, 2, 3. So 64 should be ages 3. The array sub-expression operator is used to create an array from multiple values or expressions. Within the parentheses, either commas, semicolons, or even line breaks can be used to divide array elements. Although in many cases in PowerShell, an expression that only returns one value will not become an array. This operator forces the value or object to be wrapped in an array. So, names. Steve, and then John, semicolon, Jamie. This is a messy way to do things, but it does work. Abigail, comma, Serena, comma, Callie. Having everything on its own line would be much cleaner and is a common usage of this syntax. So where is index 4 in the above array? I would guess that 0, 1, 2, 3, 4, so it should be Serena. Let's test this since I'm not 100% sure. So let's save and then do a measure karma. Please wait while we examine your karma. So the new update should have some sort of no, I don't think I have loaded the module yet. So it allows the collection. Ah, no, it was right. So Serena was index 4. So I was counting correctly. Okay. Then we move on to it allows the collection to be split into multiple parts. So here we do ages equals 11, 18, 25, 74, and 19. And then you can split it in by assigning it to multiple variables at once like this. So $Jim, $Ashley, $Teresa, $Bob, $Janice equals ages. So in this case, Jim should be 11, which is the first one. And Bob should be 0, 1, 2, 3. So 0, 1, 2, 3. So 74 should be Bob. Arrays can be unevenly split by specifying fewer variables. So in this case, I would guess the remaining numbers would be added into the others variable. So Jim and Ashley would take the 2 first, and then 25, 74, and 19 should be others. Does it read this correctly, or do we need the at notation? Let's check. It's much slower to measure the karma today, for whatever reason. So at line 69, no, it was correct. So we didn't need the at notation of, okay, so that's nice. So if you know the contents of the array and want to skip specific elements, you can assign specific elements to $null to discard them. $null is one of PowerShell's automatic variable values like $true and $false and cannot be altered. Any data you attempt to assign it to it will be ignored. So $null, $1, and $2 equals others. So it will be ignored. So that means that this should be 25 then. Let's try that. Oh, it said 74. I got the answer. I just realized that I cheated. So 25, but it says that it should be ignored. It would just, oh, so it doesn't skip it, it just adds it into nothing. So it should be 74. So let's move on to the next one. It lets you build a subset of the original array. So here we have an array containing the numbers from 1 to 10, and a start which is blank and a finish which is blank. So here it wants us to pick a range of indexes, which is noted with this dot dot notation. So an array from start to finish should be 6, 7, and 8. So that should be 0, 1, 2, 3, 4, so 5 to the last one should be 6, 7. And you can select specific index numbers. So here we want from the array we want index 1 and index 4 and an index which is blank, so so index 1 would be 2 in this case, and index 4 would be 5 in this case, and we also need index or the value 9, which would be the index 8, so index should be 8. It allows use of negative indexes, so array is 1 through 7, and array -1, what is the -1th item? It's actually the last item in the array, so it should be 7. Negative numbers can also form a range and extract subsets. So array from -4 to -1 index should be 5, 6, and 7. Would anything be missing here? So -4 should be -1, 2, 3, 4. And -1 should be 7, yeah. I think we are missing number 4. And in this case, we need an array with index -3, index something, and index -6. So index -3 is 5, index -6 is 2, and we also need the value 1, so that should be -7. And the last one is you can make clever use of this to reverse an entire array. So last index needs to be a negative number, so we need the array from -1 to last index. It should be -1, 2, 3, 4, 5, 6, 7, so it should be -7. So let's measure our karma. See if we got everything correct. So expected null on line 103. Yeah, so we got everything correct. So we're up to 21 Koans. So on to the last one on arrays. I think we're going to do two or three Koans, I guess, or something like that. It does not throw exceptions with invalid indexes. Yeah, so we have an array from 1, 2 through 4. It allows negative indexes, but what about indexes out of range? So array index 4, we have just 0, 1, 2, 3 here, so should be null, I guess. I think so. Negative 10, I don't know. Null as well. Let's try to measure karma here. I would expect it to be null, but since they... Yep, it would be null. Yep, thanks. These kind of trick sentences kind of throw me off here. Let's move on to assignment and arithmetic. So we are up to 22 Koans now. Assignment and arithmetic operators. Just like many other programming languages, Powershell has special operators designed to work with data. You can use the following command to get full overview of how operators work. Get help about operators. Loosely, operators fall into a few categories: assignment, arithmetic, comparison, redirection, and string operators. In terms of order of operations, Arithmetic operators typically execute before comparison operators, followed by string operators, redirection operators, and finally assignment operators execute last. So let's start with describe assignment operator. It is used to assign a value to variables. So this is the equal sign, which is the assignment operator. So here we have expected value equals 1 plus 1, or is assigned 1 plus 1. An actual value in this case should be expected value. So this would be 2 in my head. It is also used to assign a value to properties or elements. With arrays, we can assign values directly to indexes. So here we have an array containing 1 through 3. So here we say that array index 2 should be 5, or should be assigned 5. So in this case, the array would be 1, 2, and index 2 is 0, 1, 2, so the 3, so here it would be 5. It can assign values to many variables at once, so you are able to do var1 assign to var2, assign var3, assign var4, and here it should be 27. And it can assign multiple values to multiple values. So if you do this is kind of the same thing we saw in the last topic as well, where you could assign multiple values basically. So here we have var1, var2, var1 should be correct, and var2 should be incorrect. Well, let's measure. I don't think we need to measure karma now. Describe arithmetic operators. These can be used for standard arithmetic with numerical values, as well as some limited usage with arrays and strings that can come in handy. So here we have a context addition, and it is used to add 2 items together. So 13 plus 4 should be 17. Blank plus 6 should be 13, so that's 7. And then blank should be 13.7 plus 4, so 17.7. Also can be used to concatenate strings. Blank should be hello world. So in this case it wouldn't add a space here. So it would be like this. And then my name is Jim should be my name is Jim. Yeah. And it can be used to create arrays. As we covered in AboutArrays, this is not so much adding arrays together as it is building a totally new array. It does, however, have its uses. So array is 1 through 5. New array is the array plus 7, so it will add a 7 to the last index. So match the input, yeah, so it would be just this. It behaves according to the type of the left-hand item. So here we have 10.5 plus 11 should be 21.5, or should it? It shouldn't actually, because this is a string. So it would be a new string, which would be 10.511. In this case, it would be 11 plus 12.5, so it should be 23.5. And here, 12.21. Why? Why do we need these hopelessly difficult head calculations here? So it should be 1 dot 2 2. It should be true. Adding items into typed arrays will also cause the resulting value to be converted. So here we have an array which has been typecast to an integer array. So when we try to add a string, it will try to convert this to an integer. So the array would be this, but with the 17 at the end. And it would have typecasted or converted it. Let's do a measure karma now just to see if we are correct so far. There we go. 998 is the next. Yeah, nice. This is how your mind is. Its light penetrates everywhere and engulfs everything. So why does it know itself? Wow. That's deep, I guess. Here we go. Context subtraction operator. It works similarly to addition. Yeah, just the opposite. So 12 minus 7 should be 5, which it would be. And blank should be 11 minus 3.5, which would be 7.5. But this cannot be used with strings. So if you try to do a hello, subtract an h, it will not do it. But when both strings contain a usable number, it will. So 4.5. Subtraction only operates on numerical values. Yeah, we can't do this on an array as well either. And then multiplication. It can be used on both integer and non-integer numericals. So blank should be 12 times 4, which should be 48. And here we have a 12.1 of a double times 2 should be 24.2. This can also be used on strings. So a times 4 would be 1, 2, 3, 4. And in this case, blank times 4 should be na 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 na. Is it a Batman reference? That's nice. So yeah, that's 4. So it should be na. Great. Context division. It is restricted to numerical use only. As with subtraction, there's no useful meaning of using division on a string. So any attempts to do so will throw an error. So hello, the string hello divided by 3 should throw. Unlike with other numerical operators, however, division often results in a non-integer double value when both operands are integers. So 3 divided by 4 should be 0.75, and blank divided by 10 should be 0.5. So that's 5 in this case. And then we have the context modulus. Modulus is a bit of an odd one, but common enough in programming. It performs a division and then returns the integer value of the remainder. Yeah. So it's usually used with integers. So the remainder of 15 mod 7 should be 1, I guess, because 7 will divide by 14. And when we have 1 left, so we should have 1, which like this. It cannot be used on non-numeric values, so expected message should throw an expected message. Only a partial matching phrase from the error message is necessary. Let's just try to run these. So if we add this, we should be okay. If you have trouble, try doing something similar in the console to see what happens. Yeah. Was I supposed to just try something here? Wouldn't this be the same message? So it says that system object does not contain a method name op modulus. So for some reason it doesn't give the same error. I don't know why. So let's just do this. Okay, moving on. Let's measure the karma just to see that we have did the modulus thing correctly. Wasn't really used to doing the should throw expected message stuff. But yeah, we are on line 178, which is the next one. Yeah, nice. Out of nowhere, the mind comes forth. So we have one left in about assignment and arithmetic. I think I've streamed for about half an hour now. So we'll complete this and then we'll end the stream, I think. So describe assignment arithmetic combination operators. So this can be used to simplify expressions. With only assignment and arithmetic, some expressions can get a bit unwieldy. So value is 5. And then value should be value plus 5, which should be 10. Yep, we can combine the two. This is what they mean. We can combine the two to increment or decrement a variable. So in this case, we have a value which is 12, and then we use the plus equals operator to tell you that, or to tell PowerShell that we want the value to be itself plus 7. So then we end up on 19. And we can use the same with negative. So value minus equals 3 should be, in this case, value would be 19. So minus 3 would be 16. And we can even combine multiplication and division with assignment. So value divided equals 2. So it should be value divided by 2. And in this case should be 8. And the same with multiplication. So value should be value multiplied equals 3 should be value times 3. So we have 8 times 3 should be 24. And you can do it with modulus as well. So we have 24. Here we have value 12. And then we have a value modulus equals 4. So we should have value mod 4. And 4 actually divides by 12, so modulus would be 0. Okay, let's measure karma for the last time today. Oh, come on. Here we go. We are moved on to about comparison, and for some reason 3 of them already are completed. But we are up to 41 Koans, and yet the same quote, out of nowhere the mind comes forth. So yeah, thanks for watching, everyone. I'll get back with the continuation of this in the next time. So thanks, guys.